Assalamu alaikum, dear students. Welcome to my YouTube channel, Math Expert Students. If you are new here, please do subscribe my YouTube channel. Click the bell icon. And if you have any question related to these topics, you can send us by email or in the comment section. I will solve and send to you. Email is given in the description of the video. So today we will discuss about Laplace transform, and specifically we will discuss second translation theorem, or this is called second shift theorem. So the statement of the theorem statement is, if f of s is equal to Laplace of f of t, you know that this is Laplace of f of t, and alpha is greater than 0, then Laplace of f of t minus a u of t minus a is equal to e raised to power minus as f of s. Okay, students, this is the second translation theorem statement, where u is the unit step function. I write here the u is unit step function. Okay, now we will use the definition of the Laplace transform proof. For proof, it is simple. You know that the definition of the Laplace transform 0 to infinity e raised to power minus s of t, which is called the kernel of the Laplace transform, f of function f of t minus a, then u of t minus a, and then we have dt. So we have just need to apply the Laplace transform on this function. So we have 0 to infinity e raised to power minus s of t, f of t minus a, u of t minus a dt. I simply write this. If I break this integral, you know that if we have an integral from a to c, then we write this a to b and then integral b to c. So similarly, we can use this result here. I have integral 0 to a e raised to power minus s of t, f of t minus a, u of t minus a dt, plus then I have a to infinity e raised to power minus s of t, f of t minus a, then I have u of t minus a, and then dt. Okay, students, this is very simple. We break the integral into two integrals. Now you know that here I use the definition of the unit step function u of t minus a, which is equal to 0 when 0 is less than or equal to t is less than a, and is equal to 1 when t is greater than or equal to a. So here 0 is less than t is less than a. So this part is equal to 0, and this is equal to, this thing is equal to 1. So I can write it here. I can write here simply 0 से infinity e raised to power minus s of t, this thing is equal to 0, f of t minus a, and this thing is equal to 1, and dt. So we get 0 से infinity, okay, e raised to power minus s of t, f of t minus a, and dt. Okay, students, now we will use here a substitution. Let I call v is equal to t minus a, and dv is equal to dt. And now our Laplace is equal to Laplace of f of t minus a, f of t minus a, u of t minus a, which is equal to integral 0 to infinity, integral 0 to infinity, sorry, a to infinity, not 0 to infinity. I put here again the limit is 0 to infinity, a to infinity. Okay, this is limit from a to infinity. A to infinity, e raised to power minus s into v plus a, v plus a, f of v and dv. So can I write this e raised to power minus s of a integral a to infinity, a to infinity, a to infinity, e raised to power minus s of v, f of v and dv, which is the definition of the Laplace transform e raised to power minus s of a Laplace of f of t. So students, if you have any question, you can send us via email or in the comment section. We will solve and send to you. Thank you.